to my video. In this video we're going to be looking at a searching algorithm for AQA's GCSE in computer science. This is part 1 of a 2-part video. The searching algorithm that we're going to look at is the binary search. A binary search is an efficient method of searching for an item in an ordered list. In your exam you may be asked what the advantage and disadvantage of a binary search are. You may also be asked to compare them to other searches such as the linear search. The disadvantage of the binary search is that it will only work on data that is already in order. This is definitely a disadvantage as the linear search does not require this. The key advantage of the binary search is that it's more efficient and it's quicker in finding or identifying whether the information that you're searching for is within the list. It does this by halving the data at each step. The key steps of binary search are: it firstly calculates the midpoint. We then check if the midpoint is equal to the item that we are searching for. If it's not, if the item that we are looking for is less than the midpoint, we repeat the above steps on the left hand side of the data. If it is greater than the midpoint, we repeat the steps on the right hand side of the data. Here I have got an example of some data. So it starts at 17 and it works its way up to 37. In order for a binary search to work, it requires the data to be in order, and this data here meets that criteria. Another thing I'd like to point out that the linear search is normally less effective than the binary search in most cases. I'm now going to do a step-by-step walkthrough so you see how the key steps work. This will help you create some pseudocode or a flowchart or maybe even the program at a later point. So the first thing that you need to know about is the left pointer, and the left pointer points at the furthest left point of your data, and that a right pointer points at the furthest right point of your data. The midpoint is basically the middle point, but this needs to be calculated. So the first thing I'm going to do is place the indexes on. We've looked at indexes in previous videos, and just to clarify, the index is basically the location of where each piece of data is. So for example, if I said what was at location 5, you would say 28. What was at location 1, you'd say 20. It could also be said like this: what is at index 2? 25. What is at index 6? 34. What is at index 5? 28. Okay then, let's calculate the midpoint. So we take the left pointer's index, which is 0, and we add the right pointer's index to it, which is 8, and we then divide that by 2. This would give us 4. This means that our midpoint is at index 4, so 26 is our midpoint. Following the rules from the previous page, we are in a moment going to check whether or not that 26 is equal to the value that we are searching for. In this case is 28. But firstly I'd like to point out that I've now got a left side of my data highlighted in green and a right side of my data highlighted in orange. Let's check if that midpoint is equal to 28. So I've got 26, which is here. This is my midpoint. Is 26 equal to the value I'm searching for, which is 28? Well, that is in fact false. So what that means is, because a binary search requires it to be in order, because 26 is less than 28, we know that anything from here backwards, the left hand side, is too small. So we can no longer pay attention to that data. So therefore I can ignore it because the data can't be any of those. Okay, so now my new left pointer is at the most left point of the data we're interested in. At this time it's at index 5. My right pointer is still at index 8. We now need to calculate a new midpoint. So we take 5 because it's the furthest left, and we take 8 because it's the furthest right. We add them together and we divide this by 2. This would give us 6.5. This leads us to a small issue. There isn't a value at 6.5, there's no value here. So we need to apply something called integer maths. And basically this just disregards anything after the decimal point. So here I've got 6.5. Now a lot of people make the mistake of by just doing this, and they go, oh, I've done it, I've got rid of it. Well no, because that's still a float or a real. Okay? What it means by integer math is you treat it as an integer, it's a whole number. So you just keep the 6. So our new midpoint is in fact at the 6. So therefore, our new midpoint is 34 at index 6. We now need to put our left and our right on. So our left is highlighted in green and our right is highlighted in orange. Let's check if the midpoint of 34 is equal to 28. Is 34 equal to 28? False. So therefore, we know that 34 is greater than 28. So therefore, anything from this point onwards, the midpoint onwards, is too big to be the number we're looking for. Okay, remember, that's the reason why it requires the data to be in order. So therefore, we can wipe that away and ignore it. That's of no longer any interest. Interestingly now, my left pointer is pointing to the most left point, which is 5. And my right pointer is pointing to the most right point, which is also 5. Let's calculate the midpoint. You can guess what's going to happen here. 5 plus 5 is 10 divided by 2 gives me 5. So my new midpoint is in fact there. Okay? Let's check if my midpoint is equal to the value I'm searching for, which is 28. 28 is 28. True. So therefore, this means that we have found the item. I just want to point out, let's pretend that you weren't searching for 28, you were searching for something else. Okay? Actually, let's make it even easier. Let's say that 28 wasn't there and you were searching for 28. When you get to the end, what that means is that if you were searching for 28 and this value here wasn't 28, it means it's not in the list. I hope that helps. Okay, just to clarify, the key steps are: it calculates the midpoint. It checks if the item is equal to the midpoint. If it's not, and the value we're searching for is less than the midpoint, it will repeat it on the left-hand side of the data. Okay? If it is greater than the midpoint, it will repeat it on the right-hand side of the data. And remember, the key factor that the binary search requires is the data is in order, and it is more efficient than other searches, such as the linear search. Thank you for watching. I hope you enjoyed this video. Remember, there is a part 2 coming where I look at the pseudocode with a walkthrough using a trace table and a flowchart. Thank you.